Okay, I think we are more or less on time. So let's get started here. And next to welcoming all of you to this session, of course, I would like to introduce our speaker, who is Professor Francesco Fatone. He is Professor of Chemical and Environmental Engineering in the wonderful area of Ancona at the Adriatic coast. In his presentation, essentially summarizing results from the EU-funded project Smart Plant, will focus on circular economies with innovative wastewater treatment. So Francesco, it's a pleasure. Just take it away.
Thank you very much, Igor, for your presentation, introduction, and I'm very pleased to be here, also virtually, to present how innovations can deliver circular economy and how we have been addressing this issue within the project. I'm also Water Europe ambassador dealing with the value in water, and I'm also secretary of the International Water Association Resource Recovery Cluster. So I'm dealing with this issue at the European level, but also at the global level. And I will be very happy to discuss with you what are the European priorities and approach and the global approaches. In terms of contents, I'm going to address the three pathways of resource recovery: energy, materials, and water, focusing also on the need of value and safe resources and reuse that we need to aim. And as the topic of this event is smart, I'm also specifying how digitalization can support the circular transition. Even saying a few words about the barriers. So if we consider the value in water, of course, we have to take into account that the first target should be always to optimize the water treatment and, if possible, water use. So the first mission. But if we consider the pyramid, the more is the volume, the less is the value. But the more is the value, the more are the safety requirements and the risk to be managed. So energy is probably the resource with higher TRL, technology readiness level, but probably the TRL is lower if we consider the carbon footprint and that is related to energy efficient and energy positive treatment plants. This is an example of how the cumulative energy is increasing if we are decreasing the limit for discharge. And here in this graph, we can clearly say how decreasing the limit for discharge, we are increasing the carbon footprint. Well, dealing with energy, the energy positive treatment plants have been developed over the last 15 years, and we have full-scale examples, but most likely the best evolution has been the Power Step Horizon 2020 project coordinated by the Berlin Competence for Water that has demonstrated how we can increase energy positivity up to about 150% by the scheme AB plus optimization, anaerobic digestion, and power to gas area, together with the advanced nutrient removal via nitrate removal. So out of this innovation action, we currently have very ambitious projects, and this is an example from Denmark. The Evidencebased Water Resource Recovery Facility is aiming at having energy positivity 150%. So this is the status of energy. High TRL, full-scale challenges. What about other resources that we can recover? Well, here I have selected some slides that have been presented by the European Commission at the workshop that we did together June last year. Well, the European Commission has funded many projects about resource recovery from the urban water cycle for more than 200 million euros. In all these projects, resource recovery has been delivered in terms of nutrients recovery, mineral fertilizer and biofertilizer, but also in terms of added value organic materials such as biopolymers, such as cellulose. And as you can see here, we have several innovation actions that have been concluded or are ongoing that are demonstrating in real environment the potential of resource recovery. But after all these efforts, all these investments that are mainly at demo to full scale, if we consider the last circular economy action plan, we can see that still water is considered for nutrient management, and water is everywhere and nowhere. So wastewater was considered an untapped resource, but actually in the current European programs is not central. On the other hand, as we discussed also today, these years are the right momentum because we are reviewing a lot of directives. We are introducing the new circular economy action plan. We are under revision of the urban wastewater treatment directive. So most probably our major efforts and contribution are very relevant exactly in this moment. So when we have to address the materials recovery, if we only address the technology, we are only addressing one side of the problem, because the challenge is to keep the technical value of the material, to keep the technical value of material, considering also the regulation and legislation, the end of waste criteria, and together with that, we have to enable the technical skills of the water utilities. So we have to integrate the existing asset by solutions that are close to what is already in place. Not to have a revolution, but to have a gradual integration. This was exactly what we did. We did the Smart Plant Innovation Action that started in 2016 and was successfully concluded in 2020. We were integrating existing wastewater treatment plants in Europe in the Mediterranean basin in order, first of all, to reduce the energy footprint and the carbon footprint. That was the first point that we were asked from the water utilities, and in parallel to recover materials such as struvite, calcium phosphate, phosphorus biofertilizer, and organic material such as cellulose and biopolymers to finally deliver safe products for users or industries such as construction material and biocomposite. All this taking always into account, as you can see, the water quality that had to be delivered finally. So here in this slide, you can see the different treatment plants that we were integrating with our solutions. And we are going from 40,000 population equivalent to 2 million population equivalent. And we are going from Israel to UK in order to have also solutions that are at a different latitude, at different conditions, at different treatment schemes with different utilities, completely public, private, or completely private. In terms of technologies, we were aiming at integrating the different steps from primary to secondary to the sludge line. And here you can see the treatment plant, the key enabling process, the smart product, so the product has been recovered from wastewater, and also all the technologies were considered for the environmental technology verification, the European protocol to validate the performances and certify the environmental performances. Well, finally, after 4 years, we found what we call the evidence-based results. In particular, we were able to demonstrate the quantity of cellulose that we can recover from municipal wastewater, 2 to 7 kilos per person per year. How many polyglossacanoate biopolymers you can recover, 1 to 1.2 kilograms per person per year, calcium phosphate, struvite, mineral fertilizer, but also biofertilizer. All these solutions in combination can deliver energy saving from 4 to 68% and reduction of carbon footprint together with the sludge reduction. This was the first interest of the water utility, and this was the added value. What we have to consider is that some of these materials currently are considered still a waste in many European countries. So that's a major challenge. In terms of market, it's very interesting to say that the most interesting from market side is probably the biopolymers recovery that is addressing the plastic market, but it's also slower in terms of time to market. On the other hand, the fertilizer industry has quite fast time to market, but the volume that you are producing from wastewater treatment plants is sometimes not of interest for large fertilizer industry. So an economy of scale is needed there. Very important here is the role of digitalization to monitor the efficiency and the quality of the material that we can recover. But the question was also, what about the governance? When we are recovering resources, we have to understand what is the benefit for the water user. And in fact, we were addressing this issue by using the national regulation for water utilities, the water tariff, and understanding what can be the change of water user bill if we are splitting the benefit to the water user and to the utility for new investment. And here you can see, of course, we have an impact that is not that relevant, but there is an impact that we can report here. As I mentioned, the digitalization is a major challenge and can support circular economy. What we were demonstrating is how we can monitor the carbon footprint together with the resource recovery in order to drive and support the decisions in plant operation to optimize the greenhouse gas emission. So here you can see now we have sensors that are able to monitor energy. We can couple with the lab data and we can use greenhouse gas emission measures to cluster data, to apply data analytics, and to drive the operation of the plant to optimize also the carbon footprint. So altogether is in line with the Green Deal, of course, but at the end we were addressing practical issues that were related to the national legislation and European legislation. We were discussing a lot with the national government, with the European Commission, and finally, we understood that we have to act local to impact global. And this is an example, is the new draft decree for sludge management in Italy, where recovery of biopolymers, cellulose, nutrient is considered as a possible option. And this is a first important step, because so far there was no mention at all about this possibility of resource recovery. We still have a lot of barriers to address, and that's crucial to consider the customer behavior, the user behavior, and it's crucial to consider the current rules of public procurement that is focusing on low cost instead of closed loops. At the moment, except for fertilizing products, we don't have an harmonized European regulatory framework for resource recovery. And we have also to consider that as long as we don't have a clear target, for example, as the target that we had for the energy sector, maybe we are not pushing enough towards resource recovery. Of course, end of waste is a major issue, and we need an harmonization of end of waste at European level, and also a promotion of public-private partnership in order to make stable this connection between the water sector and other sectors. In Smart Plant, we demonstrated the connection between water sector and construction sector. I mentioned this importance of risk management, and this is very relevant for materials recovery and also for water use. The risk management approach should go from the treatment plants to the final user, that in this case is the human being, of course. And to address the risk management, we cannot have only a focus on the treatment plant, but we should focus on the full chain of the integrated urban wastewater and reuse system. So water use has to start from the sewer system. This is what we are doing in Digital Water City, coordinated by the Berlin Competence for Water. And in particular here, we are testing a digital solution to understand the illicit connection in sewer, to deliver early warning system to address the health risk by validating solutions to minimize the risk starting from the World Health Organization guidelines. So we are bringing together the technical language and the health need, the health standard to finally have a clear risk matrix optimized according to the new regulation. How digitalization can support water reuse as a primary resource to be recovered and reused? Well, by matchmaking the need of agriculture and the supply we can get from wastewater treatment. And what we are doing in Digital Water City, we are measuring the water footprint of the local and peri-urban agriculture, and we are matchmaking the demand and the offer by a digital platform that will be developed in fireware. All this together with a clear measure of the carbon footprint and energy footprint, because we have finally to deliver a solution that is holistically sustainable. So that's it for my presentation. It was fast, but as you understand, resource recovery is not only nutrient, but is nutrient and whatever has value. Thank you.
Thank you very much, Francesco. Just in time, perfect presentation. I would like to encourage you to put your questions into the Q&A box on the main platform. We can also do it like this. You know, if you switch on your camera, I know that someone wants to ask a question. I think we are only 30 people here, so that also would make sense from my point of view. And to a little bit kick this off, Francesco, you know, I saw, you know, you named different benefits from your circular approach, but what actually is the major driver for water utilities to deliver circular economies? What do you think?
Yeah, I think the major driver is to have the water utility as a major networker to deliver circular economy, because the water sector compared to other sectors, for example, of the circular economy action plan, is quite lateral, is quite limited, but the water sector is transversal. So the interest of the utility is to connect to other sectors and to have new activities intersectoral, where still the water utility will have the same mission, that is to treat water, but together with that will be to produce new materials and to have specific activities to put these materials into the market. So to be central in the circular economy strategy, the water utility has to change probably the mindset and to feel as transversal, not only as water oriented.
Understand, yeah. I don't see any questions yet. Please, you know, oh, here, Peter Hartwig, please go ahead.
Hello. Thank you for this really interesting presentation, Francesco. I have one question. If you have an anaerobic digester, in plants we try to put in also other organic residues in the frame of co-fermentation. How do you evaluate this, and what is your vision for future to use it more, this technology? So to just use the existing digester to feed more organic in.
You know, the anaerobic co-digestion is my first love. Actually, my group was working on anaerobic digestion for the last 40 years. So you're actually the right person. Of course, I think it's a great opportunity, even because our anaerobic digesters, further to the wood urban framework directive, urban wastewater treatment directive, are now underloaded. So they were designed for higher loading, and we have a lot of volume at European level that we can fill with other sources. The point is what to do with the digestate, because if your sludge is high quality, your digestate will still be high quality when you put food waste, for example, in. But if you are treating even industrial wastewater, your final digestate is going to be not high quality. So, for example, you cannot go to agriculture in case you're considering agriculture. So the fate of digestate is one of the main factors to consider to drive a decision. But co-digestion in terms of optimization of the integrated resource management, it's an excellent idea.
We see the development in Germany more or less that all the sludge is going to incineration, and then from the ashes we make the complete phosphate recycling. And in this view, there it's no problem to have also some substances, because it will all be removed during the process.
Yeah, you know, it's a matter of organic. Right today, I was mentioning to Richard that I was filling one of the stakeholder questionnaire for the new sewage directive, the current discussion. It's a matter of organic content into the soil. So if finally we are going to the agriculture, we have to consider carefully incineration, because if we need organic content to the soil, we cannot have incineration of clean material such as the food waste. On the other hand, if we have enough organic content to the soil, of course, incineration can become the first priority. So, yeah, depending on the country, on the soil characteristic, different decisions are needed probably.
Any more questions? Please switch on your camera that I can address them. Then I would go forward with another one, Francesco, and that is more, oh no, here, Carsten Benneker.
Yes, thank you so much.
Ahead. Sure.
Thank you for your interesting input, Mr. Fatone. Your final statement was that recovery is not only about recovering nutrients, but also maybe other interesting products. It leads me to two questions. First, maybe what about the carbon? Is there a path that makes sense to return carbon to soils in terms of regenerative agriculture? And the second, what are promising products that might be interesting for the industries that come out of wastewater treatment plants?
Thank you. Thank you very much for your question. Well, the project we had is one plant that is one I am also promoting, is to recover organic material that is the highest values as possible. So the carbon that is going to be back to the soil is probably one of the lower market value, but can have a very high environmental value when we miss organic content into the soil. On the other hand, if we recover biopolymers from sewage sludge, what I was presenting is quite relevant, because 1 to 1.2 kilo per person per year can be a very interesting new income for the water utility and can feed the bioplastic industry. Or if we recover cellulose, if we recover alginate, this material can be reused in the construction industry. So my point is, let's always consider the pyramid, and if we are able to recover safe material, so if the biopolymer that we recover are safe and there is a market for them, so we can have the end of waste, that should be the priority. Once we recover all this material, there will be still carbon left in our sewage sludge, and that carbon, if we don't have high concentration or relevant concentration of emerging contaminants, has to be considered also for land application or for incineration if we don't need carbon to the soil. So there are countries like the Netherlands, they have a national roadmap with the priority substances, and they have selected, for example, cellulose, biopolymers, alginate, that are also related to technologies that are in place. So we have full-scale plants that are currently being constructed, and I think that this is the forthcoming future.
Thank you so much.
You're welcome.
Yeah, Krugman, please.
Hi, thank you very much for the input. So I'm not at all an expert in water. My field is urban planning and urban design. But I liked very much your statement about water utilities being transversal and also the infrastructure that they have. And I'm wondering, I'm currently trying to answer questions around how energy and water and other means and other urban resource flows connect with urban planning. And my question is, and I know of a project in Berlin that recycles the water on a local level, so on a block level. And my question is whether there is any advantages of doing that on a very local level, almost a micro local level, than doing it at a really huge plant.
Thank you. Thank you, Georg. That's also very interesting and important question, because yeah, I eliminated that slide from my presentation, it's very nice to see, if you consider the white paper on circular economy of water from the MacArthur Foundation, you will see that the water use is considered at local level. Why? Because the closer is the site that you are addressing, the lower is the risk. Because if you are closing the loop at the building level, for example, you know for sure which is the source of that water. So if it's sustainable, because that is the challenge, the right technology that is sustainable, the more you go decentralized, the more you need targeted technologies that are ad hoc developed. The more you go, you know the source, the better and the safer is the recycle. When you have centralized solutions, you should understand what is the water that is collected, wastewater that is collected into the sewer. And it's not easy to find illicit connection. Today we had a very nice presentation about how to manage with digital and smart solutions the sewer system. That is still a challenge. So once the water is bad quality for emerging contaminants, for example, or for hydrocarbons or for heavy metals, cleaning that water is a challenge and the risk has to be managed. So I think the centralized solution should be promoted, but taking into account the economic sustainability that quite often is difficult to handle. We have to consider that the water tariff is very different in Europe. In Germany, 1 cubic meter is, I don't know, 3 to 5 euro. In Italy is 1 to 2. In Denmark is 7 to 9. So depending on the country, also something can be or not sustainable from an economic point of view.
Thank you very much. Comprehensive answers. Yeah, I think we have to jump over to the main stage where we will hear a summary. So Francesco, once again, thank you very much. And to the audience, thanks for joining this one. See you on the other side of this meeting again. Bye.
Thank you. Thank you. Bye-bye.